3 examples here. These are different. Now they're saying, hey, listen, you have an exponential function. We're telling you it's exponential, and we're giving you just a couple values to start with. Now, will you fill in the rest? Will you draw a sketch of the graph? Will you write the function? So if we know this is exponential, then we know that what's going on here has to be based on multiplication. So we know we're multiplying by 2. If it were linear, we'd say we're adding 5, but this is not linear, it's exponential. So we keep adding by 2 every time, and we fill in the rest of this table. So we multiply by 2, sorry, did I say add 2? I meant multiply by 2. So you get 20, multiply by 2, you get 40, multiply by 2, you get 80. So we fill in that table. Now, where's our starting value? Remember, that's always paired up with the 0. So we've got our starting value, in this case, of 10. So we can write that over here in our function. F of x equals, remember, starting value times the multiplier to a power of x. Forgive me. To a power of x. Now, what are we multiplying by? 2. So we've got our function written there. 10 times 2 to a power of x. Now to sketch the graph. It starts at 0, 10. So up here somewhere. Well, I'm just going to scale it a little bit. And I know it's growing because I'm multiplying by 2. So I know that this graph, as I go to the right, it's going to get big in a hurry. It's going to plane out as I go to the left. Because I'm multiplying by 2, it's going to grow as I go to the right. Again, down here, starting value, multiplier, always have an exponent of x. Example D. Again, they tell me it's exponential, so I know I'm multiplying. Here's the trick, though. I multiply by some common ratio, which we don't know yet. I have to do that twice to get from 100 down to 1. This is a tricky problem. So not only I'm going to have some unknown value in between here that I need to figure out. So I know that I took 100 and I multiplied it by r, not once, but twice, and I get 1. That means 100 times r squared equals 1. That means r squared had to be 1/100th. So that indicates that r must be 1/10. Wow, that's a toughie. So 1/10 is my r value. Now we also know our starting value is 1. So if we want to write our function real quick, it'd be f of x equals 1, that's our starting value, times our r value, our common multiplier, of 1/10 to a power of x. That means that we have decay. This thing's going down. If I multiply by, let me get it down to where I can replace these r's now with 1/10. So I'm multiplying by 1/10. I'm multiplying by 1/10. Keep doing that. Multiply by 1/10. Multiply by 1/10. If I keep doing that, that means my values here, 100 times 1/10 is the same as 100 divided by 10, which is 10. 10 divided by 10 is 1. 1 divided by 10. 1/10 divided by 10 gives you 1/100th. I prefer fractions over decimals. Now what's happening here to these values? They're going down. They're decreasing. So I know I had a starting value at 1 over here, starting value at 1, and it's going down as I go down the table. So these are going to decrease. But that means if it goes down to the right, it must go up to the left. It was decreasing all along the way. We get these nice smooth curves. This is considered decay. If I were a person and I'm walking, I'd be going downhill. It'd be a decay. Again, rewind, check it out, but this is the hard part right here. Figuring out that r value, knowing that we skipped a value in there. Finally, example D-E. They save the best for last. This is linear. That means that every step along the way here, I must have been adding or subtracting. So if we go from 10 to 30, I am adding some common difference. Every time, some common difference, some common difference. Now, how many of these common differences did we add? I count 4. So that means to go from 10, I had to add 4 of those common differences to get to 30. So let's solve this equation. Divide by 4, and you get D equals 5. That means that every step along the way, I was adding 5. So let's get rid of those D's, and change them into what they are, which is plus 5. So now we know what goes in here. 10, 15, 20, 25, and it works out. 30. Great. So my starting value is at 15, and I know I'm going up by 5 every time. So we can write our function. Remember, it's going up by 5. That's a positive 5 as my slope, and I started at, remember that value over here, 0, 15. So that's my starting value. Now remember, this is linear. We've done so many curves. Now you got to remember that you have a linear. So it starts at 0, 15. Let's plot that point. And it's got a positive slope of up 5 over 1, up 5 over 1. So they're just asking for a sketch. So we know that that line is going to be going up like that. Again, rewind, listen to the videos if you need help. Otherwise, get started on those 506 practice problems. Thank you so much, folks. Have a great day and a great weekend. I will see you on Monday.